Hello everyone, I'm going to try to do this video for astronomy. Uh, if there's any issues with it, please let me know. I'll redo it. I kind of want to do this one really fast. I hope I'll have, when you do a calculation, I'll try to have an example calculation in a video either at the end of this one or in a separate video. Um, this is about the night sky. This is a very pretty picture, this first picture. This is uh, you can see the archway of the rock. This is somewhere in Utah, in the desert, and we're looking towards the north, and we're seeing the stars that are moving around. You can see that some of them move in a circle. Let's see if I can get a laser pointer here. Yeah, you can see right in here that there's stars moving, and what appears to be a circular arc. That they're never going to set below the horizons. That's kind of an unusual thing. If you look at the night sky and you're in a very good spot for looking at it, you can see about 2,000 stars with the naked eye. And you can see some other features here. You can see the background. Basically, this is the Milky Way, the galaxy that we're in. You can see this is a massive number of stars and clouds of dust and gas that we can't distinguish into the nearby stars that we should be able to see, but there's billions of stars in this across the sky. And of course, we can see stuff on Earth too. Um, and when we study the sky, we tend to break it up into regions. And I want to be careful here. You've probably seen the pictures of, like this is Orion, and there's, this is supposed to be a hunter with a sword and shield, and below here is a hunting dog and another hunting dog. And I think this is some sort of snake or reptile. I'm not sure. But those are what we call asterisms. They're patterns in the sky. Um, when I was in school, I learned the Big Dipper to us looks like a dipper to, other people. Like, say, in French, it might be referred to as the plow. It kind of looks like a plow. Um, and the whole constellation is named after the big picture that looks like a bear. So the constellation is the region of the sky. In these pictures, there is this not quite rectangular area drawn, nice straight lines and everything, drawn around the asterisms. And there's 88 of these regions that cover the entire sky. All right, so I want to be careful. The constellation is just an area in which we've designated it as having some name. The asterism is the pattern that we see with the stars. And you can see different patterns. Right, so we're going to do a separate video where we look at planetarium software. Um, the stuff that I'm going to use in the course is called Celestia. There's also Google Sky. There's Stellarium, which I think is expensive, but apparently very good. But your planetarium software will show you the divisions of the constellations and the asterisms in it, and so you can see the Big Dipper, you can see the Little Dipper, and the Dragon, and you can see the people, Cassiopeia and Perseus and Andromeda, and here's one named after a triangle, the Triangulum, and the chariot wheel and such. You can see a lot of different uh, patterns, but you also see where the regions are divided up. So the stars are all at different distances, and someday I hope to have a model of this in 3D that shows you, from one perspective, what the constellation, what the asterism looks like, and from a separate perspective, how far apart the stars are. Um, But in the meantime, looking at the night sky, they all look basically at the same distance. They are different brightnesses, but they all appear like they're projections. And so we pretend mapping things out. Since we can't tell distance in naked eye observation, we're talking about that they're all projected on a celestial sphere, and then we just talk about distances in the sky, uh, transverse distances, not radial distances. So, everything looks like it's at a fixed distance on a sphere, and the constellations cover the sphere. All right, so there's southern constellations down here. Generally, the northern constellations are named for things that the ancient Greeks saw, and for ancient Greek mythology. And then the stuff in the southern hemisphere tends to be named by whatever was reasonable to the explorers who who went from Europe into the southern latitudes and observed. And so you see some interesting ones there. Right. And so there's some other features along here that we'll talk about. The ecliptic is the path of the sun through the celestial sphere. And because the Earth's axis is a bit tilted, the ecliptic is tilted relative uh, to our equator. Right? So everything else we project from the Earth. We pretend there's a little light at the center of the Earth. And so the Earth's North Pole maps out to a North Celestial Pole, and the South Pole maps to the South Celestial Pole, and the equator maps to a celestial equator. These are all projections of features on the Earth out onto the celestial sphere. The ecliptic is special, the sun traces that out. There we go. North Pole is above the Earth's North Pole, South Pole's above their South Pole, and the equator is above the equator. So the Milky Way defines the plane of our orbit through the galaxy. Basically, we are moving around the center of the galaxy, and if we look towards that center, we see a massive grouping of stars, billions and billions of stars and dust and gas and nebula that cause us to look basically like spilt milk. So that's the Milky Way. So the reason it looks the way it does is because we're looking basically edge on towards the center. There's a lot of stuff in one plane and not that much stuff in other directions around it. And so if our solar system's here, we're going to see lots of stuff towards the center, not so much other stuff towards these spiral arms that are coming out, and much less stuff looking out of the plane of the galaxy. So if we want to map something out on the sphere, we have a few different ways of doing it, and one of the ways we'll talk about is saying, well, how far above the horizon is it? What's the angle that it makes with the horizon? And then how far along, in which particular cardinal direction are we needing to look? So we talk about altitude and direction. Direction is also called azimuth. And then there's particular points that we care about. The horizon, necessarily the place where you see the ground. Instead, what we say is that directly overhead is what we call the zenith, and 90 degrees from that is the horizon. Generally, that's the place where you see a water horizon. Like if you're at the ocean and you can't see land, you can see the horizon. There's some cases where you can see it other places where the land's nice and flat, but in general, you don't see the full sky all at once if you're in a location that changes elevation. And then we have the meridian, which it starts at due north, travels through the zenith, and goes due south. So think of it kind of like a line of latitude. It's a line that goes overhead and projects from your from your line of longitude out. It connects in the south and goes through the zenith. And there is also the point directly below you that has a name. It's analogous to zenith. It's called the nadir. So if you've heard that in language, is zenith is like the highest point you can see. The nadir is the lowest point. And so it tends to be used for, sounding like things are bad instead of good. Okay. I had to stop for a moment and do some stuff. That's okay. Slides. Come on, slides. So when we can't talk about radial distances, how far away something is, because we can't really measure that by naked eye observations. We end up having to talk about angles. And so, um, you know, essentially the angles ignore how far away something is. They say, how much do you have to turn your head to see the shift in position? And so there's some easy estimates. A fingertip at arm's length is about 1 degree. Your hand spread out is about 20 degrees, and a fist is about 10. And so when you look at the sky, the moon is about half a degree. The dipper in the Big Dipper is about 5 degrees wide. If you go in the southern hemisphere, the Southern Cross is about 6 degrees. And Orion, if you see it coming up, is about 20 degrees. It's probably the biggest asterism in the sky that you can recognize. Right. So, in greater detail, just the edges of the moon are separated by about half a degree. And from your homework, you should know that's about 3,500 kilometers because it's relatively close to us. But we couldn't necessarily reason that it's close to us or very, very big and very far away. Right? Not until we had techniques to measure it. So we've seen, talked about this, the distances between noticeable pairs of stars or the distances on your outstretched hand. And we'll come back to that in a bit. So in your math, you know that a circle is 360 degrees. You should know that it's subdivided. A degree is 60 minutes, and a minute is divided into 60 seconds. Those actually come, I think they're French. Like, there's a minute part of a circle or of a degree, and then there's a second minute part, which is where you get seconds from. But either way, this is a ancient system, and the terms that we use for it are just relatively, simple. And so these seconds are very, very small, and that tends to be the sort of thing that you need telescopes to measure, and what a lot of the measurements that we make nowadays are. They're in very small amounts of arc seconds. All right, in the homework, there's a question about Betelgeuse. I swear it's pronounced like that. Betelgeuse. Betelgeuse. That was some small number of arc seconds. It's a subject that's very, very far degrees, and it's something like 10 to the